In this video, I'm going to be talking about how to do integration by parts. So if you know the formula, it goes like this. It goes uv minus vu dash. So that's really all there is to be doing integration by parts. So to illustrate this, I'm going to be going through these two examples, x sine x and how to integrate sine inverse x. So the first one is just to give you an idea of how to do it. The second one kind of shows you how powerful this integration by parts really is. Okay, so let's get started. Okay, so the key idea behind this is to set what is equal to u, what is equal to v. Now the idea is, okay, so I have two different things. The idea is whatever you can easily differentiate, you set it equal to u, right? And the other thing, so whatever you can easily integrate, you set it as v dash. So okay, so here we go. V dash is equal to sine x, u is equal to x. So u dash in this case is going to end up being equal to 1. The integration of sine x will end up being equal to minus cos x. Okay, so now it's just a simple matter of substituting it back into this formula. Okay, and let's do exactly that. So here's the order that it goes. Here's how I remember it, at least. You multiply these two, so you will end up with minus x cos x. Okay, and then you go minus the integration of these two multiplied. Okay, so first of all, it's these two in a diagonal, right? And the second time around, you multiply these two. But this time you're going to integrate that, so it's the integral of minus cos x dx. Okay, so I guess this minus over here can become a plus, because I can take this minus and make that a plus. But it's really important to remember that there is a minus over here instead of a plus. Okay, so that kind of catches people out, so just be careful over there. Okay, so we already got this minus x cos x part. What's the integration of cos x? Is just going to be sine x. So there you go, minus cos x plus sine x. Of course, you need to say plus c because it's an indefinite integral. But that's how you do it. Just find out what's suitable to say what u is equal to, right? And find what's suitable for integral. This v dash thing is, it's actually really important to find out what v dash is, because usually you can differentiate most functions easily. It's harder to integrate. So find out what's suitable for the integration bit, right? And it's usually straightforward. Like, I mean, I could have tried to swap these two around, right? In that case, the problem is I would have ended up with sine x and differentiate that, sure, I will get cos x, right? But guess what? If I had this instead, right? So if I had to integrate x instead, I would have ended up with x squared on 2. Now that's fine for the first bit, right? So that's fine for the diagonal bit, but I would end up with this integral. I would end up with the x squared on 2 times a cos x. So it hasn't really made this problem any easier at all. In fact, it's actually made it harder. So it's important to figure out what to differentiate and what to integrate. Okay, if you do it the wrong way around, the question gets a lot more harder, right? So that's a clue to tell you, hey, I'm doing this wrong if it's too hard. Okay, the second part of this sine inverse of x. Okay, so I need to integrate sine inverse of x dx. Before I begin this question, let me just tell you that if I differentiate sine inverse of x, I will end up getting 1 on square root of 1 minus x squared. Okay, so I'm telling you right now that's the differentiation. And in most tests, they will kind of give you this thing called integral table, and this should be in there, right? So another way of thinking about this is if I integrate this one, I will end up with sine inverse of x. Okay, so let's get started with this question. So that was a bit of a clue for me, saying sine inverse x differentiated gives me this. Okay, so in this part, I'm going to actually end up saying u is equal to sine inverse of x, because I want to differentiate that. What I'm integrating this time is actually quite a bit slightly tricky, but the trick is I'm actually going to say it's equal to 1. there's nothing stopping me from saying it's equal to 1, right? Because this over here is the same as saying multiply by 1. Okay, so u dash is going to end up being 1 on square root 1 minus x squared. B is then going to end up being equal to x, right? So now you do the usual thing that I told you before. So you multiply the diagonal. So I will end up getting x sine inverse of x minus these two multiplied, but this time integrating that. So it will be x on square root of 1 minus x squared dx. Hopefully you can see it already what to do now, right? But I'll do the slow method where I should use substitution. If you can jump to the answer, go ahead. That's great. But I'm just for everyone's sake, I'm going to do this slowly. So I'm going to say u is equal to, oops, my bad. So u is equal to 1 minus x squared. Du is equal to minus 2x dx. Sorry about that. Okay, so du is equal to minus 2x dx. So what I can do over here is, actually I'll do one more rearrangement to say that du on 2 is equal to minus x dx, right? So I'll actually concentrate on taking this minus inside and making that so I'll make that a plus and then minus x dx, all right? So now we have this integral, so we'll end up with x sine inverse of x, and then it'll be plus, okay, so that'll be du at the top, and at the bottom it'll be square root u. And remember, this is u to the minus a half, right? And because it's u to the minus half, when I integrate just this bit out, I will end up getting, so because it's u to the minus half, it'll be u to the half, and then put a 2 up there to cancel off with the half, right? So they'll cancel out with this, the half will cancel out with this one, the minus 1 will give you u to the minus a half. Okay, so the final answer, my final answer is going to be x sine inverse of x plus 2 times, now remember u was equal to 1 minus x squared, so 2 times 1 minus x squared to the half plus c. And there you go, that's the answer right there. If you have any questions or comments, let me know. Please subscribe, and thanks for listening.